Okay, here we go with geometry notes. Number 20, write and graph equations of lines. Put your name, date, and class period, please. Essential question is how do you find the slope of a line given two coordinates on 2 points of a line? And a way to find the slope when you're given two coordinate points is to plug it into your slope formula. Okay. Today's vocabulary is being able to write it in slope-intercept form, but hopefully you remember this from last year. We have y equals mx plus b, where m is your slope and b is your intercept. And also you may have your equations that are in standard form, where you'll have to move it around. Okay, first example. It says write an equation line that passes through this given point. That is going to be parallel, so we have our point, and parallel to the one equation, y equals negative 4x plus 5. So from this equation, the only thing you need is the m, which is our negative 4. Remember, when we want it to be parallel, parallel means same slope, equals same slope. I'm not going to do anything to it. And then I have to use this point to find my b. So to do so, I'm going to plug it into my y equals mx plus b, which means the 3 and the 4. The 3 is the x and the y is the 4. So when I replace it in my equation, my slope-intercept equation, the y was a 4, the m was a negative 4, and the x was a 3. And I'm left looking for the b, which is the intercept. So I'm going to do negative 4 times 3, which is a negative 12. And then I'm going to move the 12 to the other side, which makes it a positive 12. And that tells me that the b is actually 16 for my equation. So I have the slope and I have the y-intercept. I can write my equation that's going to be parallel. I have y equals negative 4x plus 16. This should be my parallel slope, or parallel equation. You can check this if you like. Go to your y equals in your calculator and type in negative 4x plus 5 for your y1, and then type in your equation negative 4x plus 16, and let's graph it. And you can look at your lines and see if they look or appear to be parallel, and they do. So that means my answer is correct. Notice my slopes are the same. Okay, on number 2, we're going to do something similar. They give me a point, but this time they want it to be perpendicular, and then there's my equation that they hand to me. So I'm going to take this one's slope now, which is a 4, and then perpendicular, the slope is different. Okay, perpendicular means we're going to do the multiplicative inverse. Okay, multiplicative inverse, which basically means to flip and change the sign. Okay, so if I look at the 4, I'm going to make the 4 a fraction, so I'm going to put it over 1, so that now I can flip it and make my slope 1/4, and this would change the sign, so now it is a negative. So this will be my perpendicular slope of negative 1/4. Okay, there's the coordinates of a 6 and a negative 3. This will be my x and my y. So I'm going to do the same process I did up above. I'm going to plug it into my slope-intercept equation. So I'm going to do y equals mx plus b. The y changes to a negative 3. The m is a negative 1/4. The x is a 6, and then plus the letter b. Okay, I'm going to see what 6 times a negative 1/4 in my calculator. It appears to be negative 1.5. And then I'm going to add 1.5 to the other side. That way I have b is equal to negative 3 plus 1.5, which is negative 1.5. Now if I put them together, that means I'll have y equals, here is my intercept and here's my slope. That'll be negative 1/4 x minus 1.5. Alright, if I check them this time, I'll go back to my y equals and clear out what I had. The first one will be 4x.
If teachers have friendly reminder.
Okay, I put in y1 4x minus 7, and then in y2 put negative 1/4 x minus 1.5, so that we can see it right there. Okay, and then I want to graph it. So I have this set up, and in the current view it does not quite look like it's perpendicular, so there is a trick. I'm going to hit zoom, and then I want to square up my screen 5. And I still think my picture, oh, there we go. So to have that set up, and then now it should be all squared up if I did that right. Let me hit it again one more time just to make sure. Uh-oh, I made my calculator mess up. Let me turn it off, turn it on, and graph. So that now if I check it, I can put a piece of paper on my calculator when I have it squared and see that that is actually a right angle. That means it is actually perpendicular, so that's a good call. Remember, to make sure your calculator is squared, you have to go down to zoom, and then number 5 is squaring it up. You can check just to make sure it's squared. Alright, number 3. It just wants us to graph this equation. This is written in standard form, so I have to get it in slope-intercept, means y by itself. So I'm going to subtract the 2x, and that leaves 3y equals negative 2x. I'm going to put the 18 behind it. Then I'm going to divide everything by 3, so that I have y equals negative 2/3 x plus, and 18 divided by 3 is 6. Alright, I want to plot it just using my coordinates I have here. I know 0, 6 is my intercept, and my slope is negative 2/3. If I plot 0, 6, and then the slope tells me to go down 2 and right 3. Remember, rise over run. Negative 2 says down 2 and right 1, down 2 and 1, 2, 3. And then I need a straight edge, which I don't have. There's one. Okay. And there's my equation. Make sure you put arrows on the end so that it shows that it is continuous and not discrete. Alright, on the next page is your independent practice problems. I want you to work those and make sure you answer your summary question on how to find the slope of an equation. Oh, I forgot your password. Let's see. Let's make it monkeys.